So today we will be seeing Friedel-Crafts acylation reaction. First of all, we will see the definition of it. When an aromatic ring reacts with acyl chloride or acetic anhydride in the presence of Lewis acid AlCl3 or FeCl3, it gives us acetophenone, where HX or CH3COOH groups will be eliminated. See, HX, when we take acyl chloride, that will be eliminated. CH3COOH will be eliminated if we take acetic anhydride in the reactants. So this reaction is an electrophilic aromatic substitution reaction. And in Friedel-Crafts acylation, we do not see carbocation rearrangement. No carbocation rearrangement, okay? So generally carbocation rearrangement is seen in Friedel-Crafts alkylation reaction, but in acylation there is no carbocation rearrangement. Now we will write the equation, general equation. Aromatic ring, let us take a benzene. It is reacting with acyl chloride CH3 C double bond O Cl in the presence of AlCl3 Lewis acid. What is Lewis acid? Chemical species that accepts a pair of electrons is called as a Lewis acid. So here AlCl3 is accepting electrons from the chlorine. Okay, we'll see that in the mechanism. And the product will be acetophenone. This is acetophenone. Now we'll be seeing the mechanism. First step in mechanism is the activation of electrophile with Lewis acid, that is AlCl3. Okay. We'll be taking acyl chloride first. CH3 C double bond O Cl. This is acyl chloride, which is reacting with the Lewis acid AlCl3. So what happens here? Chlorine will transfer its lone pair of electrons into the vacant p orbital of aluminium, and it forms a bond with aluminium, giving us the compound CH3 C double bond O Cl AlCl3. Aluminium gets a negative charge, chlorine gets a positive charge. Now as chlorine is electron deficient, it takes the bond from carbon and will leave as AlCl4 minus. Here this AlCl4 minus is a better leaving group than Cl minus. Hence we are taking a Lewis acid in this reaction, and we will get the product CH3 C double bond O. Carbon gets a positive charge. What happens here? Oxygen will transfer, it will share, it will not transfer, it will share its lone pair of electrons with the electron deficient carbon and will give us an activated electrophile. As oxygen is forming 3 bonds, it gets a positive charge. So this is an activated electrophile, also called as acyllium ion. So this acyllium ion, it will now react with the benzene, which will be the rate determining step or the slow step. The second step in mechanism, attack by aromatic ring on activated electrophile, which is also called as acyllium ion. In this reaction it is acyllium ion. Okay, the activated electrophile here is acyllium ion. So this second step is a rate determining step, slow step it is. Okay, now we'll be taking benzene ring, which is reacting with the Acylation ion CH3C triple bond O plus. Now as oxygen is positively charged, it will take back its electrons and will leave the carbon positively charged. Okay, in benzene what happens here? Let us take this carbon as first carbon, this as the second one. The first carbon will take the pi bond, will take the electrons, and this first carbon will be getting a negative charge. The second carbon will get a positive charge. Okay, negative charge, positive charge. Now what happens here? This negatively charged carbon will attack this electrophile and will give us a structure like this. C double bond O CH3, and this carbon, second carbon, will be getting a positive charge, right? First itself we have written here that it will carry positive charge. Now the hydrogen on the first carbon, it will be removed as H plus by shifting this sigma bond or single bond between these two carbons, forming a double bond between 1 and 2 carbons, C double bond O CH3, and this H plus will react with one of the chlorine groups of AlCl4 minus and will be eliminated as HCl plus AlCl3. Okay, so the product formed here is acetophenone. This is acetophenone. Okay, now this is the reaction between benzene and acyl chloride. If we take acetic anhydride, which is CH3 C double bond O C double bond O CH3, first we will be activating it with Lewis acid. This oxygen will transfer its electron pair to the vacant p orbital of aluminium, and they will be removed as AlCl3 O C double bond O. Okay, 1 second, I'll write it down. Okay, CH3 C double bond O O C double bond O CH3 AlCl3. Aluminium gets a negative charge, oxygen gets a positive charge. As oxygen is positively charged, it will take the bond from carbon, and here we will be getting our electrophile. Okay, this will be eliminated. Now this here, the oxygen will share its lone pair of electrons with the positively charged carbon and will give us Acylation ion like this. This is Acylation ion. The same mechanism continues again. It will react with benzene and forms acetophenone at last. But instead of HCl, here we will be eliminating CH3COOH. See, this CH3 C double bond O will react with one hydronium ion, which is released from this benzene ring, and it will be eliminated as acetic acid and AlCl3. The final product will be again acetophenone. So this is what Friedel-Crafts acylation is.